In this demo, I'll walk through the user interface of a 3D frame analysis tool, which uses finite element analysis to solve for displacements, reaction forces, and internal forces. Watch how to add nodes, members, supports, loads, and visualize results in a graphical 3D preview. Perfect for structural engineers. Hi everyone, welcome to this UI demo of the 3D frame analysis tool. This web app lets you model and analyze structural frames interactively. Today I'll focus purely on the UI, how to input data, visualize it in 3D, and get results. Let's start with a blank slate. First, the node section. This is where you define your frame's points in 3D space. Click Add Node to create one. It defaults to 0, 0, 0. You can edit X, Y, and Z coordinates directly. For example, let's make node 1 at 0, 0, 0. Let's make node 2 at 5, 0, 0. And node 3 at 0, 5, 0. If you mess up, just hit the trash icon. So I'll just throw one in here and then delete it. Moving to members. These connect your nodes. Click Add Member to create one. Select Start and End Nodes from the drop-down. They show user-friendly numbers like 1 or 2. Pick a section from the Save Profiles, like I-beam or whatever you've predefined. Here's me connecting node 1 to node 2 and node 1 to node 3. The trash icon removes them. Super straightforward table layout. Supports define your boundary conditions. For each node, toggle checkboxes for translations TX, TY, TZ, or rotations RX, RY, RZ. Let's pin node 1 fully by checking all. And roller support node 2 by checking TY only. Loads are nodal forces and moments. For each node, input values like Fx for forces in newtons or Mx for moments in newton meters. I'll add a 1000 newton downward force, that is Fy is equal to negative 1000 on node 3. And a moment on node 2. Set the modulus of elasticity, E, in gigapascals here. Type a custom value like 200 or pick preset values like 200 for steel or 70 for aluminum from the drop-down. Quick and global for all members. Once set up, hit Solve to run the analysis. Results appear below. Displacements, reactions are per node, internal forces are per member. Everything is formatted nicely. For example, node 1 Fy is 1015. You can see it here at 1015, MZ25, MZ25. The real star is the graphical preview on the right. It's an interactive 3D canvas. Use the mouse to orbit and zoom. Nodes are spheres. Green means it's a supported node. The labels, for example, this is node 2, N2 means node 2. These are the coordinates, 5, 0, 0. Members are cylinders. This purplish tint here means it's in compression. The gray means it's a zero force member. I don't have a tension force on here, but if I did, it's kind of a red tint. After solving, see force labels on the members, like axial, negative 1000 here, and reaction forces below the nodes. Hover or rotate to inspect. Super visual. Finally, save and load models for reuse. Enter a name and hit Save Model. Load from the drop-down or delete. Great for iterations. That's the UI in action.